Okay, this is our week 7 tutorial, and we're going to look at a specific case of factoring differences of squares. And differences of squares look like this. Let's say you have a to the power of 2 minus b to the power of 2. And the reason this is called a difference of squares is because you're subtracting, which is denoted by the subtraction symbol here in the middle, but you're also subtracting squares. Notice that both of the exponents are 2. So we have a difference of squares. And anytime you factor a difference of squares, the factorization is going to look like this. It's going to be the first base, which in our case is a, first base plus the second base, and we're going to multiply that by the first base minus the second base. Now, if we were to use the box method or FOIL, we would see that a plus b times a minus b does give us a squared minus b squared. Now, hopefully by now you remember what the squares are. For example, 1 is a square and 4 is a square. The next square after 4 would be 3 squared, which is 9. So what do you think would be next? We've got 1 squared, 2 squared, 3 squared. Next would be 4 squared, which is 4 times 4 or 16. And after that, we would have 25. After 25, we would have 36 and 49 and 64. 9 times 9 would give us 81, 100, and so on. And, we have 11 times 11, which is 121. That would be a square. 144 would be a square. 169, 225, and so on. Obviously, there are an infinite number of squares. So they do go on forever. But luckily for us, when we're taking a math class and we're trying to factor a difference of squares, normally we really don't have to go much farther than, let's say, 15 times 15. Usually the solution is going to be found a lot earlier. Normally, I would say within the first few squares. And that's what we have here in our example. I have 36x squared minus 25y to the power of 4. Now, if you look at this one is not as straightforward when you first look at it. But if you think about it, isn't 36x squared really the same thing as 6x times 6x, or 6x squared? And if you look at 25y to the power of 4, isn't that the same thing as 5y squared squared? Because 5 squared is 25, and then y squared squared is y to the power of 4. In other words, if you rewrite this difference of squares, it looks a lot more like our a squared minus b squared scenario. And since we have a difference of perfect squares, the factorization is going to be as follows. It's going to be first base, which is 6x, plus the second base, which is 5y squared. And then we would multiply that by first base, again, 6x, minus the second base, which is 5y squared. And as I said earlier, if you were to take these two factors and multiply those together using FOIL or the box method, it would take you right back to our original problem. So this is an example of factoring a difference of squares.